Greetings, everybody. So I thought it'd be helpful to make a review video about roots, also known as radicals, because in algebra class that's something that we encounter every now and then. And I know that you can calculate roots on a calculator, but I'd like you to know every way that you can do this. I want you to know what all your options are, okay? I've said this before in other videos, but part of our class being a college class, part of it being somewhat academic, is that you learn as much as you can, like that you know things inside and out. So yes, you can calculate roots on a calculator, a handheld calculator, an online calculator, whatever it is. But I'd like you to know what it means. In addition to that, I don't want you to be 100% dependent on a calculator, all right? Just as a matter of principle. All right. So as far as roots go, we can think of it like this. I'll just give you this pattern. The n root of the number a equals b. Here's what that means. It means that if you take b, the answer, to the power n, you'll get a. A lot of things in math have a pattern kind of like this. But we can say, all right, if b's the answer to the n root of a, then if I take b to the power n, I'll end up with the number a. Okay, so that's the meaning of it. You know, that's what this says. It's a pretty simple pattern. Okay, so let's go through some examples for me to illustrate that. The third or cube root of 27 is equal to 3. And the reason that that's true is if I take 3 to the third power, I will get 27. You can try it out. 3 to the third power is 3 times 3 times 3. Multiply those together one at a time, you'll get 27. The fifth root of 32 is 2. Well, okay, so if I take 2 to the fifth power, then I'll get 32. And it's true, 2 to the fifth power, 2 times 2 times 2 times 2 times 2 is in fact 32. The square root of 25, the second root of 25 is 5. Ordinarily, we would just omit that 2. We wouldn't write it, it'd just be like this. 5 to the second power, 5 times 5, 5 squared is 5 times 5 is 25, okay? All right, so here I have these worked out already, but I mean, I guess if you had one that you hadn't seen before, such as, what if we need to do the fourth root of 81, okay? Suppose we had to figure that out without a calculator. I know you can do it with a calculator. That's easy. You just press the buttons. But remember, I want you to know things inside and out. I want you to be independent. I want you to understand the way things work behind the calculator. So here, if I say I wanted to do the fourth root of 81, okay, then I'm thinking like, oh, there's some number that's the answer to this. That if I raise to the fourth power, then I'll get 81. And I guess like if I thought the answer to this was like a nice round number, a whole number, you know, not every root has an answer that's a nice round whole number like 3 or 2 or 5, but if I thought that that was true with this one, then I might just go down the list. Is the answer 1? Is 1 to the fourth power 81? 1 to the fourth power is 1. 1 times 1 times 1 times 1, that's 1. Maybe the answer is 2. 2 to the fourth power, is that 81? Multiply together, 2 times 2 times 2 times 2, that's 16, so that's not it. Eventually, I guess I'll probably find it. Let's see, 3 to the fourth power, 3 to the fourth power, 3 times 3 times 3 times 3 is 9 times 9, and that is 81. Okay, so that's how we might go about this if we were going to do it just with our minds, no calculator, okay? And I realize you might not want to do it that way because calculators make it easy, but I think it'd be bad if you're in a technical field of some kind and you know, you might know how to use the calculator and that's great. They save time, they make things easy, but then if you had no clue what a root actually was, that would worry me kind of. All right, that'd worry me a little bit. Okay, let's do one more. What if you have negative numbers, like third root of negative 64? So same thought process. Third root of negative 64 is negative 4 because negative 4 to the third power is in fact negative 64. Try it out. This negative 4 times negative 4 times negative 4, that's going to be positive 16 times negative 4. And if you take positive 16 times negative 4, you will get negative 64. Okay. What about, let's do one more. What about this one? The square root, and I'll go ahead and I'll write the 2. Square root of negative 64 is negative 8. You know, I mean, I can actually have a root of a negative number like this one. This one has an answer. But does this one? And the thinking's kind of the same, right? What's 8 times 8? 64. So what if I throw a negative in there? Would that make it right? Let's see. If I take negative 8 to the second power, will I get negative 64? If negative 8 is the answer to this, then that's how it would work. Okay, well, let's try it. Negative 8 to the power 2, multiply by itself twice, is equal to negative 64. If negative 8 is the answer, that's the way it would work. But negative 8 times negative 8, a negative times a negative is positive, so the answer is positive, and I'm going to get 8 times 8 is 64. So no, this one is not correct. The answer is not negative 8. In fact, there isn't a number that you could square and get negative 64 or negative anything, because any negative times any other negative is positive. Okay, so all right, you know, this one, no, that wasn't right. You know, I proposed it to you, wanted you to think about it, I wanted to explain why the answer wasn't negative 8, but in fact, this one, there isn't a number, right? What did I say? That any number to the second power won't be negative 64. It won't be negative at all. So this one, our answer is not a real number. Okay. There are such things as imaginary numbers. I know that must sound ridiculous that there are imaginary numbers, but it turns out they're very practical and they explain a lot of things about the world. That are the answers to negative roots like this, but you know, at least for us, there is not any ordinary number as people think of numbers that would be an answer to this. Okay, all right, so I will leave it at that. I'll leave it at that. This one has an answer. You can in fact take an odd root of a negative and it will have an answer. It will be negative. Okay, but you cannot take an even root of a negative and get a real number, a number that you understand as a number. Okay, those won't work out. Same thing but true if I had a fourth root of a negative and so on. Now, as I've given you all these examples, these have all been answerable as 3 or 2 or 5 or whole numbers, nice round numbers, negative 4. You know, we do encounter roots that aren't like that, like the square root of 5. Like, I cannot give you any nice round number that if I square it, I get 5. There just isn't a number like that. So in those cases, you know, we will have to rely on a calculator. You know, that's not something I can very easily do in my head. And then we get a decimal that in fact keeps going beyond what you see on this screen right here. Okay, the decimal expansion of root 5 actually goes on forever. We cannot write down the whole thing, so we're going to have to round it. So I might say that in this case I would have to use a calculator. This is not something an ordinary person can do just in their head. So we'll say 2.236 with rounding it to the third decimal place. All right. So an equal sign would not be appropriate. I am rounding this number, and so I use my approximation symbol and say 2.236. I wouldn't use the equal sign because I actually can't write down a decimal that's perfectly equal to this. I will have to leave some of these digits off. Like I said, they keep going past the screen, so I'd say no matter what, I cannot write them all down. Okay, it's actually not quite proper that my online calculator here wrote equals. This is definitely rounded as it is right there. It's an approximation. Okay, so sometimes for something like this, then we absolutely, most likely are going to use a calculator for it. Okay, so that's a crash course on roots. Okay, I hope that's enough to at least get you acquainted enough with roots to get through algebra as you might see them. And of course, if you run into anything along the way that you don't understand, send questions about it to me, send them my way, and perhaps I'll make another video that could help you or anybody else.